Hey Thor, think you need to take off the mute. All right.
Okay, I think I'm good to go. Sorry. Yeah. So one thing I'd add is when I first started Scala at Kayak, it was on a team that was doing using Spark, and I joined because as a Scala hobbyist, I was the most knowledgeable person in the organization. So that was quite the learning experience. Obviously, we can't take time to fully learn the language before getting going on uh, organizational priorities. So there was a lot of learning and anti-patterns. But yeah, that was quite an experience. I'd also mention that I recently started contributing a little bit to Core Scala. I was scary at first, but not as scary as I thought it would be. So if you are at all interested, I would suggest giving that a go. This talk, if you've been a little bit lost with all of the type class talk in previous talks, hopefully this talk will be a lot more accessible. It's aimed at relative newcomers, people who, if maybe heard about type classes, are still trying to figure out how they work, when to use them, etc. Uh, I assume that you know enough about Scala 3 to kind of understand the syntax. Um, but I'm going to go over an example that for me really sort of made type classes click for me and kind of more in general moved me from writing just merely better Java to writing idiomatic Scala. Um, and this example is going to be quite a bit more simple than some of the type classes we've seen. So if you don't understand type classes, hopefully it'll help give you enough of a base that you can go tackle some of the more complicated type classes, like perhaps some of the ones from cats that you saw in Michael's talk. Um, all right, so what is a type class? It's kind of like the functional programming equivalent of an interface that you might see in object-oriented programming languages, and it supports sort of ad hoc polymorphism. So it kind of gives common behavior to types that might be completely unrelated. So it might do things like handle comparisons or encoding and decoding instances from various codecs, how different types compose, especially when you're dealing with some of the like heavy duty type classes you'll find in the cats ecosystem. Um, they let you extend the behavior, but you don't have to extend the class, which is extremely useful if you're working with like legacy code or Java classes, where you might be trying to get two libraries work together and you don't really control the source code in either. Um, so it can be very, very good for sort of glue-like applications. Um, One important thing to note when we're talking about type classes, which kind of originally did from Haskell, um, they're not actually first class entities in Scala. This is a subtle point. Um, we encode type classes and traits, but traits are not type classes themselves. So, like in Scala, all type classes are encoded as traits, but not all traits are type classes. Even if you see, a type class with a single parameter, um, that is in a given, it still might, or a trait with a single type parameter that is uh, in using given or implicit, if you're using Scala 2, doesn't necessarily mean it's a type class. Um, all right, so a little more about type classes. Uh, Type classes in general should be about something canonical, something sort of that is always true, almost mathematical to some degree. Like you shouldn't ever really have different for a given type class instance for a particular type. You shouldn't really have different implementations or different results. Um, so, like things like mathematical properties are good for encoding in type classes, but it doesn't necessarily have to be mathematical, right? Like if you're encoding something into JSON or some other codec, it should always encode and decode the same way. Now, because of this, you usually find type classes defined in libraries, rarely in business logic, because business logic can change with mutating requirements. But a good sort of way of thinking that you've got if you write a type class once and then rarely change and then almost never change an implementation, obviously with the exception of bugs, it's a good sign that you've picked the right tool for the job. And yeah, so like, does this mean that you have to be working on some third-party library? No. Like, if you're working on any sort of large project in some organization or you know, enterprise level, you're often gonna write sort of like private libraries, right? Like, a lot of projects have this sort of common library that handles like nuts and bolts kind of thing that you typically write things like how to log, or how to communicate, or how to read and write from configuration. Those sorts of things you tend to write once and they're reused within the organization. They might not necessarily be applicable outside of the organization, but they're usually written, especially with third-party libraries, but also these sort of libraries, with the intention of making integration and bringing your own types into the type class easy, which is it tends to be a little more easy than if you're just implementing a trait. So another way of putting this is type classes should never be subject to product requirements. If you find that your type class is changing because of a product requirement change, it probably should not have been a type class in the first place. All right, so where can you find these? They're like all over the standard library, with things like ordering that are used for sorting lists, etc. Spark makes use of them, most notably in its encoder for data sets, to like transform a case class into a representation that can be easily distributed without having to completely deserialize it into a Java object. And then there are just all over the type level ecosystem. If you're going to use the type level ecosystem, you're going to run into piles of type classes. You got a pretty good overview of a bunch of these in Adam's talk. All right, so the example I'm going to use is from a config library, specifically the Lightbend, formerly Typesafe config. I think that's what it's still called in the if you go and add it to your build.sbt dependencies. And the Java ecosystem, being in the Java ecosystem is very convenient because, especially at an enterprise level, a lot of times there will be code you need. It's not always present in Scala, but we can operate with Java really easily. The one problem is the ergonomics in Java are very different, and the way we write code can be very, very different. So, for example, this is the interface we have when we're working with the Typesafe config library. It's not bad, but it's very Java. Having a different method for every type is not something we typically do in Scala. What we'd like to do, like if we were writing this in Scala, what we might like to do is instead have something very simple like this, with just a single get method that takes a type parameter and a path. This is typically how we like to do this, and we'd like to do this in a way where we still have type safety while we are doing it. All right, so how do we get there from nothing with type classes? So we're going to build up our API. Here's our type class. It's this simple trait. We're going to call it extractor because it's going to extract a config from a config file, extract a configuration object from a config object instance. And I often find it's helpful. I'm not sure. I don't think this is different in Scala 3, the implicit not found. I don't think there's like a given not found, but it's often helpful to add a custom message if the type class is not found, so that someone in your organization who or outside of your organization is just familiar where to look for more information on the type class if they forget to add it for whatever type they're trying to work with. But yeah, that's pretty much it for the type class. And to finish our API, because we'll add just this extension on config that uses the type class. It's important to note that this is not part of the pattern itself, and this is unlike some of the things you saw in Michael's talk where there are extensions on type T. This is not an extension on type T. It's an extension on config, so it's not related. It just kind of it's how we're going to use this type class. This describes how we intend to use the type class. All right, so the first type class we're going to make is just simple getString, right? This is the full syntax for it. If you're familiar with Java, you'll notice this alternate syntax, the single abstract method that is used to make it a little more concise. I'll be using this for the rest of the talk, the more concise syntax, just because it's a little easier to fit on the slides without making tiny, tiny font. But yeah, so we'll start with this first pass. We're just basically going to include all of our any vowels, and there's some more things there's some more, but I'm just including some of the basics. So it's useful to note that if you run into a type class that you did not write, the authors usually will have already implemented all of this stuff, and sometimes if they're fancy, they'll also have some auto-derived type classes like the ones you saw in Catrus's talk right before this. But yeah, this is our start. This is where we start from. All right, so what does this get us? This is what we had before. This is what we have now. It's not that exciting. Gets just a little, but it does look more idiomatically like Scala. However, what if these described some more complicated object, right? Like I've used in this example, host port, whether to use HTTPS. This could describe the configuration for some REST interface. And so what we can do is then, we can build an extractor for our REST interface, or for the REST config for our REST interface. And what we would do is, now that we've built this extractor, which basically takes the path, it pulls out a config, a subconfig. If we pulls out a subconfig and then pulls out each of the individual members and builds a REST config with that. And what this gets us is now we don't have to repeat ourselves. So when we have this extractor, let's say this is our config file that has two different services that use the same thing. Our usage for it is now simplified. Anytime we have a REST config that we have to pull out of our configuration file, we can just reuse this. And this is something we couldn't do in Java. You would have to make it a bit more clunky, but it's very nice and reusable in Scala in this manner. All right, so this is a pretty simple case so far, but what about optional members? Our configuration library throws config exception .missing if you enter a path that is not there, and we don't like unchecked exceptions in Scala. And on top of this, yeah, we would prefer to just use options if something may or may not be there. It does not, despite the presence of optional in Java, I don't think it is widely used. I remember getting annoyed at all the nulls in a Java code base I was working on and trying to introduce optionals and being told, please don't do that. I think there might have been some performance reasons or something else, but that was a little frustrating. But in Scala, they were totally normal. So without making any additional type classes, if we're going to pull an optional parameter out of our configuration, this is what we got to do. We got to call if config.hasPath port return some config.getInt with the port. Otherwise, none. So we're basically just checking that the path exists before we try to extract our configuration from it. What we'd like to be able to do, and that's what's more idiomatically Scala, is to just say, if we have an optional parameter, just get the option, right? Get option.int. So how can we do this? Well, as you heard in Michael's talk, type classes can be built with other type classes. They're inductive. So in this case, rather than having a concrete type class on the bottom, what we do with writing options for every possible one is we write an option type class that takes a type parameter. So as long as we have some type T, we have an extractor instance for type T, it's easy for us to build a type class for type T, for type option T. So this is how we do it. And so now we have something like this. We don't have to clutter up our configuration with that big ugly block of code everywhere. It gets kind of abstracted behind the option type class. And one nice thing about this is it makes it really cleaner for the end user and really obvious what's going on without exposing him to any of the messy details, right? Because, you know, the option, how we extract an option wasn't super messy, but it definitely was not, it's more code that someone has to look at, and this just expresses what's going on much more concisely. So one other thing that this allows us to do is now maybe we want to go add another extension method, right? This is pretty common that we want to get, if something is optional, we would like to include a default. Well, now that we've built an option type class, we can go and extend config to have a get or else that leverages this option type. And as long as we have an extractor of type T, we should be able to get or provide the default. And so now, if we were to go back to the REST config that we were working on before, we can just replace, let's say we're going to make port and use HTTPS optional. We can just replace those with get or else with their defaults. Now we are handling sensible defaults. Everything looks really nice. So that was one of the simpler kinds of higher kind of types that we could include in our type class. What about another? Let's take lists. One thing about the Typesafe config library is it provides lists for a lot of primitives. And so we're going to go through and add a bunch of list extractors. You don't have to use a higher kind of, you can just add an extractor for the base class if they're available, right? So in this case, Typesafe config provides getString list, getInt list, getDouble list. Just using those is probably easier than writing a generic, although we'll still need to do that. But this also illustrates another thing that we can do when we're solving this particular problem is that you'll notice that in this case, a Typesafe config returns a Java collection, and we're always going to want a Scala collection because we're working Scala collections. So we hide the conversion from a Java collection to a Scala collection in the extractor, so that is hidden away from the end user. They don't have to worry about conversions when they're writing their own configuration extractors. And the other thing is when a Java class is not returning a primitive, it's returning a box type. We also have to convert that box type to Scala, and we can handle that here as well. So what about a more complex type? So let's say we have a list of what we were talking about before, our REST config. Now, one thing you might notice here is that there's a little bit of a problem. So here is we have our get config list, which basically takes if we were to call it on services, it would give us a subconfig for each of those blocks. The problem is our type class requires a path. So our type class is basically get and then the type in type parameters and then the path. The problem is we don't have a path here. So let's say we want to solve this quickly. We might come up with a very hacky solution. In this case, what we are doing is we're getting the list of config options, and then we are sort of wrapping it in a map with an extra key, an extraneous key, so that it will work with our existing type classes. So if we're going to get a list of type T, if we have an extractor for T already, we can reuse that extractor. It's a little bit hacky. I'm sure if you spent time, you could probably come up with a better way of doing this, but you don't have to. And if it works, and this does work, I have compiled this and run it and tested it. It definitely works. I've got it still ends up hiding the messiness of this from the end user. Which is, I think, in my opinion, one of the goals of writing good library code, because a lot of the times you will have to do some wonky workaround, and this helps abstract away those messy details from someone who just wants it to work. All right, so using list extractors, now that we've got them, this works. And when this works, it uses the extractor that we built for the type list int. And this also works, and it uses our generic list extractor combined with our extractor for a REST config. So if we want to support additional types, let's say you want to support a set because you have a lot of things that you just expect in sets, and that is not on the Java API, right? Because the Java API, it has a method per type, it's kind of restricting, right? They obviously can't add one for any imaginable type, or they probably don't want to, because that would just blow up the size of their code to an unreasonable size. But in here, we can just do something like this. It's pretty simple. We reuse the list extractor. We can make a set extractor that takes of type T, that takes a list extractor of type T, and just converts the whole thing to a set at the end. It's very simple code, but then it prevents you from having to repeat yourself down the line if set is something that you use very frequently. And then the last example I'm going to show is maps. So sometimes you might want to have a config map, right? Because you might not know which configuration to use at compile time. It might depend on some other data. So you might have a configuration that looks like this. And so you've got a set of REST services with labels on them. And then you've got, what we would like to do is just be able to get a map. Now the map is, we already have a map-like structure, but again, we might, if we're going to do a quick, dirty implementation, we might use something like this, which it's a little bit messy, but we get a config at a certain path, and this config is thought to be our map, right? It's got a key, which is a further path, and a value, which is not. And so we will call something like this, where we get the config, then we extract the keys from the entry set. There's no key set for this object, and then we convert it to Scala, and so we have a set of the keys, and then we just iterate over those and build a map. Again, there's possibly better ways to do this, but you can hide that from the end user who just wants it to work. And yeah, that's my last example. I'd like to give a thanks to Justin for convincing me that I had something worthwhile to talk about, and Mark for walking through my talk and helping me refine it a little bit. And I have some additional resources. I'll post these in my channel. I found this article, Implicit Design Patterns in Scala. It focuses on Scala 2, but it's written by Lee Hauyi and was very, very well done, and did a great job of explaining this to me when I had no senior engineers to explain it for me. I'll have the repo for this talk. Feel free to stop by my channel. And also, I mentioned contributing to Scala before. I encourage you to check out the Scala contributors channel on the Scala Discord, or go to the board for Scala contributors. You get to see how the sausage is made. You can lurk for a while before you decide to try your hand at stepping in or contributing. That's what I did. And if you want to get involved in type level, I encourage you to stick around for the round table at the end of the day. And that is it for me.
Right. Thor. I can hear feedback again. Right. Yeah, really proud of you. I remember you saying this was one of your first talks at a conference. I think you did a great job explaining a really accessible and practical approach to making use of Scala with Java integration. So great, thank you. And yeah, I'll catch you on Discord. I'll stop the recording. Oh, and if you wanna say something, go ahead. I'll mute. Okay.